During the Simo Labs this semester, I let the students decide which reversing project they want to take. And I got a couple of really interesting proposals. The best proposal I got was from Ben, and he proposed to look into the SwiftKey keyboard from Microsoft for iOS. The good thing about it is, first of all, there have been some CVEs in the past, so public vulnerabilities acknowledged by the vendor. Then Microsoft also has bug bounty program, and they even have a safe harbor policy so that researchers can actually reverse engineer when they are looking for security vulnerabilities they want to report. Now, Ben decided to do another project, and I handed over the project to LOD, who was there for an internship. And I thought it's a good project for a beginner, but well, in the end, it turned out SwiftKey really wasn't the easiest one. It had a couple of very special properties that prevented a lot of approaches that I usually do on an application during reverse engineering. And we will look into the first of the obstacles here, which is the limitation of using Frida when you have memory limits. When we try to find the keyboard function in the SwiftKey keyboard, we could try the same approach as with Signal. So I do a trace, easy as that, and Frida instruments everything that has keyboard in the object name. But the next thing that we get is a crash. So Frida hooks into the crash reporter to directly show us all the crashes. We can scroll back a bit to see what the reason was. So directly here, we get told process crashed, JetSam memory budget exceeded. And a bit lower, we also see that there was a 70 megabyte limit, and it also has this JetSam code that it was killed with. Another nice thing that Frida does for us is it adds symbols in here, so we don't have to load anything into Xcode. Very nice, but also bad, because what is JetSam? Well, JetSam is the iOS memory manager, and if an application exceeds a limit, it would kill it so that it doesn't consume all the memory on the iPhone. And especially for a keyboard, that's pretty reasonable, because you don't want a keyboard that you run all the time in all applications to consume a lot of memory. What you see here is something that could happen with any application when you attach Frida, because Frida injects libraries, runs its own threads within the target process, and also all the scripts that you provide. So all the tracing scripts would land in the target process, and this increases the memory usage a lot. This can also happen when you do, for example, fuzzing. So whenever I do fuzzing with Frida, I would also increase the memory limit. When we want to change those memory limits, we have two options. First of all, there are some system-wide settings, for example, in this properties plist. But that's a lot of settings to experiment with, and maybe there's not exactly the setting that we need. And we already know exactly which process is needing more memory. For this, there's also another option just to see if Frida works once we increase the memory limit, but you can of course also use this permanently in a loop or something. So here is a repository of a JetSam control tool that works on a jailbroken iPhone. And it still works even though the releases section is pretty old. So I just click here, and then you get the latest Debian package, and you just copy the link. And then on your phone, you download this. And install it. And there we are. We can control the limit of SwiftKey. So I say JetSam control -L for the limit. And I say, I don't know, 500 megabytes for SwiftKey. Here we go. And now I try the same thing again. And as you can see, it works. I can use all the traces and the application wouldn't crash.